Cheers everybody, good morning, good afternoon, good evening, whatever time it is, hope you are well. This video is introducing circles, and it's quite a nice topic because it brings in some coordinate geometry from chapter 1, and it also brings in some of the stuff that you've done with Debs or possibly Gemma involving completing the square. So without further ado, let's jump straight into this. There's going to be a few instances where I get you to pause the video and fill in sort of bits in your notes as well, so just be aware of those coming up. Alright, let's go. To get you thinking about this, we've got a formula up here which is x squared plus y squared is 25. And what I'd like you guys to do is to try and think of numbers that you could substitute in for x and y so that the left hand side works out as 25. That combination of numbers can be then expressed as a coordinate. Now, if you're happy enough with that, feel free to pause the video at this point. If you leave it a little bit longer, then a hint will come up on the screen. Whenever you're ready, unpause the video and you'll see some more solutions. Okay, so hopefully you used that 5 and 0 combination in some other ways. So as well as x being 5 and y being 0 being a valid possibility, you could have equally had x as 0 and y as 5, and that also works. What you could also do is you can introduce some negative numbers to the works. So you could make x minus 5 and you could keep y as 0, or you could reverse that one more time. So to conclude just there, these four coordinates, all involving 5 and 0 in some way, will give us points on our circle. And I'm just going to plot those on the graph right here. Another whole number combination that you might have noticed is of 4 and 3. And as it was with the previous case, 5 and 0, we can swap the values around, we can introduce negatives, and from that we get a total of 8 more coordinates, which I've got listed here, and I'm just going to try and plot these on quickly as well. I've got one there, here and here, some more. It's counting the squares, guys, it's a little bit tricky this, and some more here and there. Awesome. Is that right? Oh no, there's definitely some wrong ones. Let's try those again. Oops. 4, 3, right, that is, where's that? It's getting late, guys. This is a struggle. There we go. Beautiful. That looks a bit better. Now that might have been all you came up with, and that's absolutely fine because you can very much see the shape of a circle taking formation there. But there are some other answers as well. You might have got answers involving surds. So I've only put one example here, but if you had, for example, root 3 and root 22, when you square them, you just end up with 3 and 22. And that, of course, that makes 25, so that would be a coordinate on your circle somewhere as well. When you join up all those points, you can see it forms a circle, and this particular circle has a center at the origin and it has a radius of 5. So it turns out that all circles have this sort of formula to them. The right hand side is always r squared. Now r represents the radius in this case. So you might have noticed in the previous example, the right hand side of the equation was 25. And that implied that the radius of the circle was 5, for example. The left hand side of the equation has got x take away a squared plus y take away b squared. Now a and b represent the coordinates of the center of the circle. So the reason why these were not present in the previous example is because the center of the circle was at 0, 0 before. And of course, if we were to sub in zeros in for these numbers here, they would effectively vanish and just leave us with x squared plus y squared. So this formula is really useful. It allows us to quickly establish the radius and the center of the circle just from the formula, or alternatively, if we had a picture of the circle and we can see the radius and the center, we can quickly establish what the formula is for that circle. Let's have a look at some examples. So over on page 104, we've got a few examples to fill in. We've also got this little reminder from the previous slide. Take a moment, pause the video if you need to, and when you're ready, unpause it and you'll see the solutions. Okay, right, let's go straight in here. So this first one has a center at 3, 4 and a radius of 2. So if I write down the equation of a circle, x minus a squared plus y take away b squared is r squared. The radius of the circle is 2, so I'm going to put a 2 over here. The center of the circle is 3, 4, so I'm going to put a 3 in for a and a 4 in for b, and that is going to give me the formula x take away 3 squared plus y take away 4 all squared equals 2 squared, and 2 squared can be simplified as 4. And that is the equation of my circle in example 1. In examples 2 and 3, we're going the opposite way. We're given the equation of the circle and we need to tell the book. Do we need to tell the book? I don't know, that's maybe a bad choice of words. We need to say what the center and the radius are. Now, one thing to pick up on and be careful with is there's actually a plus in this bracket and the formula has a minus in it. Right? So there's a change of sign there, which implies that the center of the circle for the y value is going to be negative. More specifically, the center occurs at 2 minus 1. The radius of the circle is just the root of 36, which is 6. Finally, the last example has got 2 positive values in here, which implies that the center for both x and y values is going to be negative. The radius in this case is not a perfect square, but that's absolutely fine. We can still square root this number. We can just leave it as root 20. That's okay. If you have used surd rules to simplify it, that's okay as well. You might have called it 2 root 5, and that's great if you have. Something that also crops up involving circles is this style of equation where it's not obvious at all as to what the center or radius is. In order to see the center of the circle or the radius of the circle, it really needs to be written in this format. So this requires a little bit of rearranging. It's also going to require the algebraic process of completing the square. So we'll run through this example and we'll just tidy this up as we go along. The very first thing I'm going to do is I'm going to rewrite the statement, and I'm just going to put it so that the x terms are next to each other and that the y terms are next to each other. So I'm going to call this x squared take away 4x plus y squared take away 6y, and I'm going to keep the 12 there for now. I could move it, but there's going to be more numbers to move shortly. What I'm going to do next is I'm going to attempt to complete the square for both the x values and for the y values. I'll do them one at a time. As a bit of a reminder, the completing the square process is up here. And as a sort of a verbal shortcut, what I'm doing is I'm having a look at what number is here. We've got a minus 4. I'm going to half that number. Put it in the bracket like that, x take away 2 squared. And I'm just going to take away that number squared. And I've completed the square. And I do it one more time here. This number is a -6. I'm going to half that to get -3. And then I'm going to take away that number squared. Now, tidying up this bit here and keeping the other parts, this part and this part, the same, I am going to get the following: x take away 2 squared. I've got a triple negative here, so -2 squared gives me 4. I'm still taking that quantity away. Same over here. I think generally when you complete the square, you're always going to have a minus over here. Yeah, awesome. And finally, we've got 3 numerical bits. We've got the -4, the -9, and the -12. So we're going to take all those numbers over to the right side, and we will get the following. And I think when we add these values up, we should hopefully get 25 out. Yes, indeed we do. Awesome. So now that the circle is in that form, we can read what the center and the radius are. The center looks to occur at 2, 3, and the radius looks to be 5. Cool. And that is a past paper level sort of question. So if you are happy with that, then that's great news. There might be something like that in your mark. Just maybe. So boys and girls, thank you for your patience. There's an exercise on 105, which I'd like you to give your best shot. If you want to have a look at the solutions, they are available at the end of the chapter on page 119. I will put a copy of the notes on Teams if you don't have a paper copy for whatever reason, and hopefully that sounds okay. There will be one other video explaining the stuff on 107, but that's going to be the end of the explanations after that. So thank you for sticking with me, and I'll see you all in the next lesson. Take care everybody, bye bye.